Hello, I am Opia and you are watching my channel MathyThinkers. In this video, you will learn how to solve equations with one variable. I'll show you the steps using function machines and then teach you the easiest method. So make sure you watch till the end. If you like my videos, please like, comment and subscribe for more useful and free tutorials. So please share my videos as much as you can and keep watching. To learn how to solve equations, we'll first look at function machines. Now, what are function machines? So these are simple machines which does mathematical operations. For example, suppose we have a machine which adds a 2 every time. So whatever we give as an input, it will add a 2 and give us an output there. So if we give an input of 10, it will give us a 12. If we give an input of 15, it will give us a 17. So on and so forth. So if we give an input of x, it will give us an output of x plus 2. Now suppose we have another function machine which does just the opposite. That means it should take an input of 17 and it should give us back the 15. So that's called the inverse function machine. So what it does is it does just the opposite of this operation. So it does minus 2 there. So if we give an input of 12, it should give us a 10. Similarly, if we give an input of x plus 2, it should give us x as the output. Suppose we have another function machine which multiplies the 2 every time. So if we have an input of 4, it should give us an 8. An input of 6 should give us an output of 12. An input of x should give us an output of 2x. So now let's see what its inverse will be. So if we have a 12 here as an input and we want an output of 6, we should do just the opposite of times 2, which is division by 2. Similarly, 8 divided by 2 should give us a 4. And 2x divided by 2 should give us an x. So from here we can say that the inverse of a plus operator is a minus operator. Similarly, for a minus, its inverse should be a plus. For a multiplication, its inverse should be division. And for division, its inverse should be multiplication. The next concept that we have to be clear about is the concept of an equal sign. So if we see an equal sign, that means its left-hand side and right-hand side should be same. That means if we write a 4 plus 2 on the left-hand side, it should be equal to 6, which is on the right-hand side. Suppose we write 4 plus 2 there. We write an equal sign and we write an 8 there. So that's wrong. This is correct because the left-hand side is equal to the right-hand side of the equal sign. Now suppose another example can be 8 minus 2. And we write that that is equal to maybe 12 divided by 2. Can you tell me if this is correct or wrong? So 8 minus 2 is a 6. And 12 divided by 2 is also a 6. So this is correct. So for these number facts here, if we added 2 on this side, then we must add a 2 on this side as well. Otherwise, it will be wrong. Let us see why. So 4 plus 2 plus 2 is 8. And 6 plus 2 is also an 8. So this is correct. So what if a student does 4 plus 2 minus 2 on the left hand side, and on the right hand side he did a plus 2. So 4 plus 2 was already given to us. 4 plus 2 equals 6 was already given to us. So this part equals 6 was already given to us. So this part, 4 plus 2 equals 6, was already given. And the student by mistake has taken away a 2 from this side and added a 2 here. So what he got is 4 plus 2, 6, minus 2, 4 on this side, on the left side, and 6 plus 2, 8 on the right side. So he is clearly wrong. So one thing to note here is, if we add a 2 on the left-hand side, we have to add a 2 on the right-hand side as well. Now let's look at another example here. Suppose we have 4 plus 2 equals 6. So if we have written it twice to show two scenarios. Suppose a student divides this left-hand side by a 2. And he also does the same operation on the right-hand side because he knows that whatever we have to do on the left, we have to do the same thing on the right. So this is 4 plus 2, 6. 6 divided by 2, which is a 3. And on the right-hand side, we also have 6 divided by 2, which is a 3. So 3 equals 3. This is correct. The left-hand side and the right-hand side are same. This is correct. And there is another student. What he did was, he did division by 2 on the left-hand side. And on the right-hand side, he did times by 2 by mistake. So let's see what he got. So he got 4 plus 2, 6 divided by 2 on the left. And on the right, he has a 12, which is not equal to 3. So he wrote 3 equals 12. So he's clearly wrong there. Now let's apply all these concepts learned to solving equations. So suppose we have an equation like this, which is 2x plus 5 equals 7. So we have to find out what this x is. What is this unknown x value? In order to do that, let's draw a function machine for 2x plus 5 equals 7. So the machine takes an input of x. It multiplies a 2 first. And then it adds a 5. Plus 5 there. And we get an output of 7. So that's the function machine for this equation. In order to find out what this x is, which is the unknown, we have to draw the inverse function machine of this. Let's draw that. So we have the inverse function machine going like this. It takes an input of this 7 here. And then it does something. And we should get the actual value of x there. So let's see what it should do. We already know by now that the inverse of plus 5 is a minus 5. And the inverse of a multiplying by 2 is a division by 2. So 7 minus 5 gives us a 2 here. 2 divided by 2 should give us a 1 there. So we can say our x is 1. Let's check if we are correct or not. So in the first function machine, if we put a 1 there, so 1 times 2 is a 2. 2 plus 5 is a 7. So we are correct. So that was the concept behind equation solving. Now we are not going to draw the function machine every time we solve equations, right? So we have to know the actual way of representing it using algebra. So let's do that. So if we have the equation as 2x plus 5 equals 7, so what our function machine did first was to do a minus 5 there. So we do a minus 5 on both sides. So we have just learned this, that whatever operation we do on the left, so this is the equal sign, that's like a wall. This is the left-hand side of it. This is the right-hand side of it. If we do a minus 5 there, we should do a minus 5 here as well. So we are doing the inverse of this operation plus 5. That's a minus 5 there. We want to remove the plus 5 from here. That's why we are doing the minus 5 there. So we have to do a minus 5 on this side as well. So our next step becomes 2x plus a 0, because plus 5 minus 5 gives us a 0. So 2x equals 7 minus 5. This is 7 minus 5. So 2x is equal to 2 there, because 7 minus 5 is a 2. Now in our function machine, in order to get the x back, we did a division by 2. So here, the next step is to do the opposite, the inverse operation of this multiplying by 2. So that's a division by 2. So if we do division by 2 on this side, we have to do division by 2 on that side as well. So let's see what we get. So 2x division by 2. So 2 divided by 2 is a 1. So that's a 1x. So that's just an x. That is equal to 2 divided by 2, which is a 1. So we can write x equals 1. That's our answer then. So this is correct. Okay, so now let's draw the function machine for the second question here. It says 4x minus 13 equals 15. So let's draw it for this equation. So the input is x again. So we are multiplying by a 4 first, and then taking away a 13. And that gives us an output of 15. Now, in order to get back the actual value of x, we have to use the inverse function machine. So our input to the inverse function machine is a 15. So the first operation should be an inverse of minus 13, which is plus 13. And then the next operation will be an inverse of times 4, which is a division by 4. And that should give us our value for x. So let's see how much this is. So 15 plus 13 is 28. And 28 divided by 4 gives us a 7. So our x is a 7. So let's see if this is correct or not. So if we have a 7 here, and if we times it by 4, we get a 28 there. And then if we take away a 13 from 28, we get a 15 there. So x equals 7 is correct. So now let's apply this concept here for actually solving this equation on using mathematical steps. So 4x minus 13 equals 15. So we have to first remove this minus 13 from here. So we have to do a plus 13 here on this side, on the left-hand side of the wall, which is our equal sign. So this is our wall. the equals. So if we have to do a plus, if we do a plus 13 there, we have to do a plus 13 here as well. So we have 4x minus 13 plus 13 gives us a 0. So 4x plus 0. So we don't need to write the 0 here. So 4x equals 15 plus 13. 15 plus 13. So 4x, 4 times x is equal to 28. So we did this step. Now we have to do division by 4 because we have to remove this 4 from the left-hand side. So we are going to do the division operation, division by 4. So we are doing this operation here. So we are doing this operation here. So we are doing division by 4 on both sides of our equation. So we have 4x divided by 4. 4 divided by 4 gives us a 1. So 1x. So this is just an x. That is equal to 28 divided by 4, which is a 7. So x is a 7, which is correct. Now let's look at this question here. This question looks a little bit tricky because it has an x over 2. Now we have to know that x over 2 means x divided by 2. So the meaning of x over 2 is x divided by 2. So let's draw the function machine for this. So the input again is x. So first the machine divides the x by 2 and then it adds a 13 and we have 16 as our output. In order to solve the equation, we know that we have to draw its inverse machine. So the inverse machine takes as an input of this 16. So it does the inverse of plus 13, which is a minus 13. So it does this first. 16 minus 13 is a 3. So the output is 3 here. And then it does the inverse of division by 2, which is times by 2. So 3 times 2 is a 6. So we can say x is equal to 6. So this is equal to 6. Now let's verify if we are correct or not. If we put a 6 here in the function machine, 6 divided by 2 gives us a 3. 3 plus 13 is a 16. So we are correct. X equals 6 is the correct answer. Now let's learn to solve it without the function machine. So here, the first operation should be to remove this plus 13 from the left-hand side. In order to do that, we have to do a minus 13 on both sides. So that's what we did in the first operation there, right? We did a minus 13 in order to remove the plus 13. So what we get is x over 2 on the left-hand side of this wall here. I'm going to draw the wall with a dotted line now because this is the left, that's the right. We have to remember that. So x by 2, x divided by 2 is on the left-hand side of the wall. The plus 13 and minus 13 has no effect at all because plus 13 minus 13 is a 0 there. We're not going to write the plus 0 there. On the right-hand side, we have a 16 minus 13. So x over 2 is equal to 3. Now, on the left-hand side, we have to remove the 2 from there. We just need an x equals something. We don't need the 2 there. So this is x divided by 2 on the left. We have to do its inverse operation now, which is a times 2. That's what we did here. So if we do a times 2 there, on the left-hand side, we have to do a times 2 here as well. So 2 times x divided by 2 just gives us an x. And that is equal to 3 times 2, which is 6. So x equals 6. We got a correct answer. So as promised in the beginning of the lesson, I'm going to show you now the easiest way to solve these equations. So if we have a 2x plus 5 equals 7, we just need to do something there to have x equals something on my left-hand side. So this should be our final step, x equals something. So on the left-hand side of my equal sign, I just need an x. I don't need anything else with it. So first, what we have to do is, we have to remove this number part from the left-hand side and move it to the right. So if we move a plus 5 to the right-hand side, we have to do its inverse operation. So our second step will be 2x. And we write this equals there. That plus 5 moves to the other side and it becomes a minus 5. So the inverse of a plus 5 is a minus 5. We saw that. So this step and that step are same. Here we just have moved this plus 5 to the right of this wall and taken its inverse operation. So when we move a number, we take its opposite, its inverse. So inverse of plus 5 is a minus 5. So on the left-hand side, we have 2x. And on the right-hand side, we have a 2. Now, we still have a 2 there, which needs to be removed. So now we need to move this 2. So we have to remember when we move a number, we have to do its inverse operation. So inverse operation of a times 2 is a division by 2. So we have to divide by a 2 on this side. So we have to bring this 2 here as a division. So on the left-hand side, we are left with x. And on the right-hand side, we have brought this 2 from the left to the right by bringing it as a divisor here. So this 2 and that 2 are same. This 2 and that 2 are same. So 2 over 2 means 2 divided by 2, which is a 1. So we got the correct answer. So this step and that step are the same. So we got the correct answer here. So look at this way of solving equations. See which one you find easier and follow that. But stick to one method, please. I'm going to show you 2 more examples with the method which I find easier. You might find this one as easier, the method on the right-hand side. So let's see. So on the right-hand side, here we have a 15. So 4x minus 13 equals 15. That's my equation. Again, we just need an x equals something. We don't need anything else on the left-hand side. So the first step is to remove just the number part, this minus 13. So if we move the minus 13 to the right-hand side, it should become a plus 13 here. So on the left-hand side, we are left with 4x. Then we write this equal sign. And that minus 13 has moved to the right. So on the right, we already had a 15. And when that minus 13 has moved, it has become a plus 13. So when it moves, it becomes its inverse. So inverse of minus 13 is a plus 13. So now we have 4x equals 28. 15 plus 13 is 28. Now this is 4 times x on the left-hand side. Now if we move the 4, it's a multiplying by 4 on the left. So on the right-hand side, it should become a division. So we have x, x equals 28 over 4, or 28 divided by 4, which is a 7. So we got the answer here. So this step and that step are same. When this 4 moved to the right-hand side, it came under the 28 as a fraction. So we did 28 divided by 4 on the right-hand side. Now let's look at the last question here. So we have x over 2 plus 13 equals 16. So we just need x equals something. So we have to remove everything else from the left-hand side. So on the left-hand side, we have a plus 13, which needs to move to the right. So on the left, we are left with x over 2. This plus 13 has moved. We don't need to write that. We write the equals 16, equals 16. And then we write the inverse of plus 13, which is a minus 13. So we have x over 2 equals 3. Now, this 2 needs to be removed from the left-hand side, and it needs to go to the right-hand side. So this 2 is divided on the left. When it moves to the right, it moves up as a multiplication. So x equals 2 times 3, 2 times 3, which is a 6. So we got our correct answer there. Now the last method that I taught comes in handy in situations like this, where we have a more complicated question, which says maybe 2x over 3 equals 4 over 9. So in such cases, what we have to do is, first we have to remove this 3 from the left-hand side, because we want just an x equals something on the left. This is my left, that's my right. We have to remove this 3 first. So when the 3, this 3 is it's a division, 2x division by 3 on the left. So when this 3 moves to the right, it should be multiplying by 3 there on the right. So it should move like this and get multiplied by this 4. So the left-hand side, if we move that 3 away to the right, we are left with 2x. And that 3 goes there and gets multiplied by the 4. So it becomes 3 times 4. And as the denominator, we have a 9. So now, we have a 2x there. We still don't have just an x. So we have to remove this 2 now. So this 2 is multiplied on the left. When it goes to the right, it should go as a division there, underneath there. So we are left with x on the left, because we have removed the 2 from there. On the right-hand side, we have 3 times 4 over 9. And the 2 comes there with the 9. So it gets multiplied by the 9. So we have 3 times 4, which is a 12, over 9 times 2, which is an 18. So 12 over 18 simplified gives us 2 over 3. Another way of doing simplifying this step is 3 and 9 gets cancelled, so it becomes a 1 over 3. 2 and 4 gets cancelled, and it becomes a 2 there. 4 divided by 2 is a 2. So that's 2 times 1, 2 on the top, and 3 at the bottom. So x equals 2 over 3. That's my answer. If you find the other way simpler, I can show you the way to do it using the other way. So we have 2x divided by 3 equals 4 over 9. We just need an x on the left-hand side. We don't need this 2, we don't need this 3 on the left. So the first step will be to remove the 3, to remove this. So this is a division by 3 there. So we just have to do its opposite on both sides. So we have to multiply by 3 here and multiply by 3 there as well. So here on the left, we are left with 2x because this 3 and that 3 cancel each other, equals 4 over 9 times 3. So this 3 and that 9 cancels and becomes a 3 there. 9 divided by 3 is a 3. So on the right hand side, we are left with 4 over 3. Now, next step is to remove this 2. So what we have to do is, this is 2 times x. So we have to divide by 2 and divide by 2 here as well. So 2x divided by 2 is just an x. 2 times x divided by 2 is just an x. And 4/3 divided by 2. So here we have a fraction there, right? This 2 is actually 2 over 1. Any integer can be written as that integer over 1, right? So this is a fraction division. So we keep change flip. So we keep this fraction 4/3 as is. We change the division to a multiplication, and we flip this fraction 2 over 1 to 1 over 2. So that becomes 4 divided by 2, that's just a 2 there. So that becomes 2/3, 2 over 3. 2 over 3. Thanks for watching. If you like my video, press like, share, and subscribe. And don't forget to follow me on Facebook and TikTok. Thank you.